Hello there everyone, my project is about predicting stock prices. I initially got my data from two different sources. One was the Quad1 library and the second one was Yahoo Finance, and I decided to stick to the Yahoo Finance one. So the stock that I'm looking at right now is Tesla, and the data is from its initial public offering from in 2011 or early 2012 to 2020. So about 8 years of data. So as you can see, initially I did some exploratory analysis of the data. So here, the data is from 2012 to 2021. The stock is a high velocity, high momentum stock, which has a really good run. Here I try to create a simple moving average of a 30-day time frame and a single moving average of a 90-day time frame. And as you can see from here, the 30-day is depicted by the red and the 90-day is depicted by orange. And if you have to moving average, a smaller one and shorter one, as a trader, what you could do is you could buy the intersection of the moving averages, and which will give you an edge in the market if you're trading in the market. So basically you could buy here, sell here, and make some money. Okay, so the main column that was used for the model was the closing price column. So I created a data frame using only the closing column, and then I used 80% of the data for the training and the remaining 20 for testing. So I had to scale the data first so that all the values are from 0 to 1, as you can see here, and then I created the training set, and then I also created, so I put the X train and the Y train and put it in a NumPy array, and then I reshaped the data, and then I created the actual model, the LSTM model, and create multiple layers to it, compile the model, and then actually fit the model. So we have the X train and Y train, and batch number 1 and epochs 1. So I did the same exact thing I did for the training data set. I created, I put the remaining 20% for testing. I created the testing data set, created an array, and scaled the values. So so we could predict using the LSTM model. So we convert the data to an NumPy array, reshaped it, and here is where we do the actual predictions. So now that we have the data, the testing data ready, we predict it using our model, which is LSTM, and our error rate, which was found by the RMSE, which shows to be 19.89, which is not that great, but with the high velocity, high momentum stock like Tesla, it's hard to get an accurate prediction. Here where we visualize with the results that we got. So as you can see, this is the data that the model trained on, and this is where it started predicting. So we have the validation, which is in the orange, and then we had the prediction, which is the yellow. And here you can actually see numerically how it performed. Initially it performed as, you have the value here at 56 and then 58, so which is pretty close. This is the closing price, and this is the actual price, and this is the predicted price. But as the stock was moving on and it was increasing in price really heavily, the discrepancy between the actual price and the predicted price increased, 609 versus 490. So that was the LSTM model. I'm also working on building a decision tree regressor and a linear regression model, see how that goes, and the performance, which probably those two models would be done next couple of weeks.